We talked about keeping all the HVAC, the cooling and ductwork units within the conditioned space to eliminate the typical 30, sometimes 50% losses. Well, the third way to achieve that, besides fur downs in between the floors, is to take the boundary of insulation and your air barrier boundary, which is normally at the attic floor or the ceiling of the living space, and move it from the flat to the slope of the roof. What that does is we change the point of insulation and air barrier to the roof. It makes the whole attic part of the conditioned space. It's semi-conditioned, so any losses would be to the conditioned space. So this is an easy, convenient, and low workmanship kind of way that doesn't obstruct the sequencing that contractors are accustomed to. So it's a much easier and more practical way, although it does cost a little more. But when you consider insulating under the roof deck instead of the attic floor, the added cost of doing that can often be compensated by downsizing the air conditioning and heating unit. When you eliminate losses to a hot attic, you can generally downsize it enough that you save enough money to compensate for the added efficiencies. So if you have an energy efficient shell with good insulation, airtight, good windows, and you keep all that ductwork within the conditioned space, you may need only half the amount of cooling capacity you might have needed otherwise. What's needed is a manual J load calculation. Good HVAC contractors can provide that, or energy consultants can. But without that calculation, you're likely to buy a system that is way oversized, and an oversized system is bad 4 ways. It does not dehumidify adequately. It runs inefficiently, so your bills will be higher. It also will not last as long, and of course you pay more for a bigger unit than you really need. So it's a loser all the way around, but it's what is typically done when rule of thumb sizing happens, and because they expect a lot of losses to occur with ductwork in the attic, which tends to leak as well. Another thing to point out, I'd like to point out with the HVAC system, is that the ductwork is a nice smooth metal, which allows for maintaining good air quality, but the seams are sealed with mastic, not tape. Mastic is the best thing to use. You can get mastic tape, but it's got to be installed in a very special technique. But the mastic, which is kind of like toothpaste, which is installed with a mesh and then applied over it, stays flexible, and it maintains that seal as the ducts expand and contract with temperature changes. So looking for that, and the ductwork extends down to the living area, to the middle of the house. Throw registers, send the air all across the room. You don't need the ductwork to go all the way to the walls if you have good windows, good energy efficient windows, and airtight homes. But to supplement our energy efficient heating and cooling, remember we talked about oftentimes in a very efficient building you don't need much heating and cooling, but we still need dehumidification, we still generate moisture, and we live in a humid climate. Up above the door is a whole house dehumidifier. This dehumidifier has its own humidistat and a very high capacity to remove moisture. So that can be a good investment, particularly for people with health issues such as asthma and allergies that need to maintain relative humidity below 50%. Dust mites cannot reproduce when the relative humidity is below 50%, and many people don't know that. So that is the #1 best control for dust mite allergies and often asthma. When the humidistat in the living area indicates that dehumidification is needed, regardless of whether you need cooling or not, then it kicks on the air handler, it draws return air from the house, dehumidifies it, the water drains out a drain line, and it supplies that air to the supply ducts of both of our systems. So So this is sort of the ideal. In the teaching center, we saw the low-cost option of just using a portable dehumidifier with, like people might have in their basements in other parts of the country, and then with its own drain line. So this can deal with a large house and high humidity conditions. You might also notice that there is that double pipe from the direct vent sealed combustion fireplace, so it goes through the roof. And you'll see the spray foam under this roof as well. We talked about the unvented attic, moving the boundary of the building from the ceiling to the roof. If you're going to do an unvented attic, in order to have your ductwork and your HVAC within the conditioned space, it must be done correctly. And part of what needs to be done is the insulation system must be what they call air impermeable. Otherwise you could end up with some moisture problems. That means it needs to be spray foam in most cases. So this is an open cell spray foam that has also been coated with something called an intumescent coating, an intumescent paint that provides the ignition barrier, the fire resistance you would need for an unvented attic space. And we put enough to cover the 2x8 joists, and so this provides an R30, the level that the prescriptive codes like to see and that we recommend as well. When doing an unvented attic with spray foam, what's really important also is that where the roof meets that top plate of the walls has got to be blocked and sealed. So an unvented attic must be truly unvented. You cannot put combustion appliances, a gas water heater or a gas furnace in an unvented attic. It is not safe to do that, and you should not vent for combustion appliances. Then it's not unvented anymore and you'll have moisture problems. So you can only put electric heat pumps, or if you do want gas appliances, they must be direct vent sealed combustion appliances. They will generally be very, very energy efficient, so they're a good cost-effective option as well, particularly in terms of water heating, but they are more expensive. And so that is a very important safety consideration. No combustion appliances in an unvented attic unless they are direct vent sealed combustion.